Hey guys, and welcome to the second episode of the Scripting 101 tutorial series. In the last episode, we covered the basics of Roblox Studio, the Explorer properties and everything, a lot of this like UI and everything. And we also talked about the two different types of scripts. So we have regular scripts, and then we have client scripts or local scripts. And so I'll kind of review the difference between those because that'll be important. But for today, we're going to focus mainly on the server side, so just regular scripts. But as a quick reminder, so how a Roblox game works, right? You have the client side and you have the server side. And essentially, you can think about it like Roblox has like a, they have like a server room or something. They have like a bunch of servers, right? It's a bunch of little computers that they have. And each computer sort of runs the game in the background. So you have like, when you're playing a game on Roblox, right? You join a new server, right? And every player in that server is connected to that computer, to that Roblox computer through the internet. And so you have some code that'll run on that server computer and some code that will run on each individual player's computer. And which one you use is going to depend on what you're trying to do. So there's lots of things that you would want to do on the server side, and there's lots of things that you'd want to do on the client side, right? So for example, if you are trying to get user input, so like you wanted to detect whenever the user presses the key R or something, right? And you can do a special ability or something, right? If you wanted to do that, you need to detect that input on the client side because you can't listen to the user's input from a completely different computer, right? You'd have to have the client send that input to the server, but you have to first listen to it on the client, right? But then there's other things where you don't want to do things on the client. For example, if you're trying to deal damage to another player because you just did an attack ability or something, right? You don't want to do that on the client. It's not even going to work on the client because if you do it on the client, it's not going to register for every other player. It's going to show that it dealt damage to that player for the player that you ran it for, right? For the player whose client you ran it on. But it's not going to show it. It's not going to show it in the actual game itself on the server, nor is it going to show it for all the other players and whatnot, right? So it's not actually going to do any damage. And I can kind of show an example of that. So like if I hit play, right? If you notice, so I'm moving around. I'm on the client side right now because I'm controlling my character. And if you look here, it says current client. If you go like to the home, or I believe it's also in test, current client. If I press this, it'll switch me to the server side. And you can see I can like move around. I can see my character, just like in the local testing that I showed you guys in the last episode. But what's really cool about this is I can, so if I'm on the client and I do stuff, if I kind of edit in Studio, right? So I can go up here and I can, oh my gosh, I can create a new part, right? So now I have a new part that I created, and it works like a part, right? But I created it while I'm on the client side. So if I go over to the server side, that part doesn't even exist, right? But then if I create a part on the server side, I can move it around in the same way. And it has gravity, it falls down and everything. That part appears on the client as well. But then if I move that part on the client, well, maybe it actually did move it on the server. Looks like it did actually move it on the server. There are some like weird like middle grounds where some things from the client do replicate to the server, and some things, everything from the server pretty much will replicate to the client. So anything that's done on the server will be copied to every individual player's computer to like show it. But most things that are done on the client won't replicate to the server. But some things will. So like animations, like this walk animation, it's being played on the client, I believe. Yeah, this animate script, this is what's doing all the animations. So if I turn this off, I'm just gonna kind of still, right? But it's playing the animations on the client, and it replicates those animations to the server so other players can see. So there's some things like animations and like anything that's related to like player movement, it'll usually be done on the client side and it'll still replicate. But other things like creating new parts, you don't want to do that on the client because that's not going to show that part on the server, right? Some things replicate, some things don't. And so it's important to understand what replicates and what doesn't. But for this episode, I'm not going to worry too much about that. I just wanted to kind of go into a little bit more detail on that since it's important, and we will talk about it more as we go. What we're going to do now is we're going to start with just a regular script in Server Script Service. Server Script Service is the main place you're going to put your server-side scripts. You can also put them in the workspace, and you can put them pretty much anywhere. I mean, not anywhere, but you can put them most places. But in general, I don't think you'd ever really need to put a server script anywhere but Server Script Service. I usually only use Server Script Service, but a lot of people do put it in like the workspace too. So you can like have a part in the workspace, and you add a script inside that part, right? And then that script can do things for that specific part. I don't usually like doing that, and I'll kind of explain why a little bit. It's mostly just because I mean, usually you have like, say this is like I'll give like an example, right? Say this is like a stoplight or something, right? So you have like a roleplay game, and you have like a stoplight system on like a road, right? And you want it to like cycle between different lights, and you put the script in it to like make it cycle between those different lights. Then you have multiple stoplights, so you copy paste this and have a bunch of these, right? But it copy pastes each and every individual script, and now these are each separate scripts, and so if I make an edit in this script, it's not going to make edits in these ones. And so I'm going to have to, if I ever find a bug with a stoplight script, right, I'm going to have to manually edit every single one of them. So that's kind of a pain, and there's definitely better ways to do it. So I don't usually put scripts anywhere other than server script service, because in server script service, you could just loop through all those parts and do all of the stoplights in one script. It's a little bit more complicated to do it that way, but it saves a lot of time. So my point is, put your scripts in server script service. That's what I always do, is just write in server script service. But anyway, but let's get right into actually using, like, typing stuff in the script, right? So in the last episode, I showed you this like print hello world thing, right? And if I run it, I'm on the server side, so I don't need to play it. It'll run it because the run just runs the server, right? If I run it, it prints hello world, right? And ignore this other thing. This is just from a plugin. But we can see that it runs this line of code, and this line of code just sends a message to this output window, right? But I kind of wanted to explain a little bit about like how programming works a little bit. So if you notice, we have these like line numbers, right? And I can do multiple prints, right? Goodbye world, right? I can do my name is Joe, right? So I can put multiple lines, and it'll run in the order from top to bottom. You can see it does all three of them, but it does them in the order from top to bottom. If I, move them around a little bit, it'll do them in whatever order that they appear in, right? You can see it does them in that order now. Another thing to note is that empty lines don't do anything. So you can have empty lines, and they just won't do anything. They're just kind of ignored. So you can use that for like organizing it and making it look nice. And then another thing to note, so normally, the thing, you can't just type anything, right? You can't just like type whatever. It's just going to underline everything, right? Because it doesn't recognize what this is. There's essentially, you can think about programming like a language, right? Like a spoken language, or a written language in this case. It has a specific grammar to it, and there's some things you can do and some things you can't. And so part of learning how to program is learning the grammar of a specific programming language, right? That's why they're called languages. It's because they have essentially a grammar. Or I guess you'd probably more so call it a syntax, because it determines how you can sort of organize different things, and how you can, I guess, spell different things. I don't know. But you can't just write anything, right? You have to write specific things that are part of the programming language. Like, for example, this print function is a function, which I'll get into that either later this episode or in the next episode. But it's something that does something, right? If I use these parentheses, if I do like, so just print on its own, it's going to give me an error message. But if I put parentheses around it, then it's going to run that function. And then inside these parentheses, I can put whatever I want, or specifically strings, right? So I can put put quotation marks, and then inside those quotation marks, I can put the text that I want it to put in the output, right? And so then this function, this line as a whole, will put messages into the output, right? But what I can also do, if you put two like minus signs, two like dashes, then it'll like color it gray, right? And anything after this, it'll just ignore. So this is called a comment, and essentially, it's like if you wanted to add like a note, print messages, right? You're kind of organizing your code a little bit. Other stuff down here, right? Yada yada. You write a bunch of code down here. You can organize your code like this and use these comments in order to just say, like, just add little messages in English, or in whatever language you speak or write or whatever. And this isn't actually part of the code. This isn't going to affect how the code runs at all. It's just it just exists, right? It's just there. These comments, these are for actual programmers. These aren't for the computer. Okay. So the next thing I'm going to get into is variables. Variables are going to be used pretty much anywhere and everywhere. And all these concepts are going to apply to local scripts as well, by the way. There's some differences with local scripts, but that mostly has to do with the run context. That is the context in which the script is running, which, just client versus server. But in terms of the actual programming language Lua as like itself, then it's pretty much the same between like server scripts and local scripts. So the most basic way to define a variable in Lua and in Lua as well is to just type the word local, and you can see it turns red because it's a keyword, right? Local, and then for every variable. So what a variable is, if you know like math, right, you have like a variable x, right? And x represents some arbitrary number, right? That's essentially what's going on here at programming. Programming takes a lot of terminology and concepts from math. Same thing with functions as well. I mentioned those earlier. So a variable is essentially the same thing as a variable in math, except it can store more than just a number, right? But a variable is essentially, it's telling the computer to store some bit of data in, wherever the computer goes to store it, and then assign that bit of data a name that we can use to reference it later on. So we could say local, I don't know, my name equals John. I don't know. My name's not John, but, whatever. So this local, I'll go over this local keyword later. I mean, you don't even necessarily need to do local. You can just do my name equals John. The difference between these is just depending on like what type of variable it is. But in general, you're always going to put local for most variables. Then this my name, this is just the name of the variable. So this, and that's essentially what we want to use in order to reference that variable. So, and then this equal sign is essentially taking everything to the right of the equal sign and putting it inside that name, right? So this string, John, right? It's just a string of characters. It's going to be stored in the computer's memory, in like the RAM or whatever, right? The random access memory. And in the programming language, we're going to be able to access that information from the memory using this keyword that we define. This can be anything. There's some restrictions to the names of these. So I can't like start it with a number. I can't do, right? I can't start it with a number, but I can have numbers in it as long as the numbers just aren't at the beginning. I can do capital, I can do lowercase, I can do, underscores, I can do all caps, right? I can do, there's lots of different things you can do with it, but you can't do like, operation symbols. You can't do like these, you can't do those. So it's mostly just numbers, letters, and then also underscores. You can't do like minus sign, but you also can't do spaces, right? So I couldn't do like that, right? Because then it's like, it looks like it's not giving me an error message. I'm not sure how it's interpreting this, but apparently I guess it's just, what this is doing is it's creating two variables, maybe? Oh, okay, I see what this is doing. This is interpreting it like this. That's how it's interpreting it. So when you put a space, it's actually, so one thing with Lua, and as well as, Lua is you can actually do multiple things on the same line, and you can also, split them up like this. So this is creating like one variable called hello, and it's not setting any value to it. And then another variable called world, which isn't local. It's a global variable as opposed to a local variable, and it's setting it equal to John, right? But basically, you don't want to do spaces in your variable names either. Is my original point. So a common way to name variables is to just if you have multiple words, then you start with lowercase and then you capitalize every following word. So like this is a sentence for a variable name, right? That's a valid variable name. This is called camel case, this way of capitalizing it. And it's kind of the standard way of doing it. You could also, capitalize the first one too, but most people don't usually, unless it's like a function name or a service name, or because you can see all these service names they capitalize the first letter as well, right? Then there's also other ways, you could do this is a sentence, right? You can do it like that. There's standards for how you name your variables, but for right now it doesn't matter too much. And then what we can do with this variable is we can access it later, right? So I can do print my name. So now instead of doing print John, right? So I can do both of those at the same time, print John and print my name. So now I'm not actually using these quotation marks anymore. And the reason for that is because I want to use this variable rather than creating a new string, right? As you can see, both of those are going to print the same thing because these strings are the same string. John is cool, right? If I change that one, it's not going to change the second one. But if I change this variable John is lame. I got rid of the quotation mark. But yeah, then if I run it, then it's going to change the second print, but it's not going to change the first print. Anyway, point is, this is a variable you can use, and you can reference it anytime after it. So after you define it, you can reference this variable, right? But you can't reference it before you define it. So you can't do print my name like that, because code runs from top to bottom, right? So essentially, it's going to be running the code. It's going to try and print my name, and it's going to see, okay, well, my name it's not anything, right? That doesn't exist. And so it's going to be confused, and it's going to say nil, I guess, because it's just not defined. Nil is essentially just an empty value. So it's, that's not exactly what we want, right? But if we change the order, then it's going to define my name, and then anything after that will have access to seeing the my name variable. And so there is also a difference between local my name as well as my name too. I'm going to do a different name so that way it doesn't overwrite the same value. John is cool. There's a difference between using the local keyword and not using the local keyword, and that has to do with scope, which we'll get into maybe later this episode, maybe in another episode. But essentially, this is a global variable. This is a local variable. So local variable, yeah, I can't really explain it without explaining if statements and functions. So we'll get into that later. But yeah, for now, just make all your variables local, and don't worry about it too much for now. But anyway, so now I'm going to talk about some different types of values, right? And we'll use variables in order to show these values. But I've already talked about strings, right? This is a string, and a string is just a list of characters, right? So you have J, O, H, and space, right? It's a list of characters, or it's a string of characters, right? They're stringing the characters together. And you define a string simply by doing quotation marks, and then putting whatever you want your string to be inside those quotation marks. Another thing, you can't do a string across multiple lines. The language kind of has a hard time with that. But what you can do is you can do a string and you can concatenate it with another string using these two periods. And you can add another string onto that string, and it'll essentially just attach them. John is lame, but not too bad. So it's one string, but it's sort of a combination of two strings. And the reason that's useful, right? Because normally you just do this, right? Where you just have one string. The reason this sort of concatenation thing is useful is because then you can do so my name equals John, local, my last name. My last name equals whack. Totally not an attempted movie reference. So now I have these two variables called my first name and my last name. Now what I can do is I can do print my first name space my last name. And so it'll make one big string that combines those two names with a space in the middle. John Whack. Kind of a weird name, but whatever. So that's a string. I'll leave those variables there, I guess. And then there's another type of variable, another type of value. It doesn't necessarily have to be a variable, but another type of value is numbers, right? And you can do decimals, you can do just regular numbers, you can even do scientific notation, which is kind of cool. But they're all considered the same type as number. A lot of other languages will consider different types of numbers to be different object types. So you could have a regular integer, right? So it's just a whole number, and you could have a decimal number, but there's usually two different types of decimal numbers. There's floats and there's doubles, which the difference between those just depends on how the computer actually processes those decimal numbers. There's lots of different ways of representing numbers, but Lua just kind of simplifies it and just has them all as just a number. So you don't have to worry about that working with Lua. 20. Sure. Okay. So those are numbers. And then another thing is going to be booleans. And it's kind of a weird word. The name boolean comes from somebody's name. I guess the person who invented it. I don't know. But basically, they're on or off values. They're either true or they're false. And these are really important in computers because computers use binary, right? And binary is it's a numbering system that has only zeros and ones. And so there's only two possible values for each position in a number, right? And you can represent that 0 as a false and that 1 as a true, or yes or no or whatever, right? And that's what a boolean is. So local example boolean, right, equals true. You just type true, lowercase, and it'll highlight it to show that like that's like a thing, right? It's not just, you know, it's not just some random string of characters that's not properly defined. It's an actual term, right? It's a value. It's true. Then you have local other boolean equals false. And these are both booleans. I always pronounce it wrong. But anyway, so then the next thing is, so those are three different types of values. There's lots of other different types of values. Those are the three I'm going to go over for now, because some of the other ones get a little bit more complicated, like with tables and stuff like that. But essentially, this is like an item that's stored in the memory, right? That's what I mean when I say like an object, right? It's some sort of item that's stored somewhere in a computer's memory. So now this value true is stored somewhere in the computer's memory, and this variable name references that value, right? Okay, so now the next thing I'm going to move on to is called operators. So what an operator is essentially something. These are I guess specifically like binary operators. A binary operator, I guess an operator is something that operates on things, right? You have your inputs and it operates on those inputs and produces an output, right? A binary operator is something that takes two inputs and produces some kind of output, right? And so a lot of the common binary operators are like, for example, I can use print statements here. And the thing with all these different types of values is you can print all these as well. You don't have to necessarily print a string. It can convert these to strings. So I can print all these. And if you notice, I'm like putting commas between these. For now, you don't really need to worry about how that works too much, but basically this is just going to put a space between each of these items. So I'm providing three values into the print function. And how the print function works is it's just going to concatenate those three values as strings with spaces in between them. So this is like, I could turn these all into strings, doing toString, right? I don't remember what was there, I guess my age. I can convert it into a string, and I could do toString, example boolean, toString, other boolean. And I could like, oh my gosh. Oh, that's not right. I can put spaces between these, so I could do like, I could do like this, right? And so this toString function is just going to take, you can input a variety of different values, so like a boolean or a number, and it'll turn it into a string of the same value essentially. So like toString of my age would just be a string with the text 20, right? Or, you know, with the booleans it'd be like true, right? Or false, right? So that's what toString is doing. So it's turning them all into strings, right? Then I'm concatenating those strings using this concatenation operator, which is an operator. It's an operator, which is what I'm about to get into, right? And so you can concatenate those with spaces. But a shorthand notation for doing all this is just to use commas, because the print function will automatically turn them into strings, and then if you provide multiple things into the print function, it will concatenate them with spaces. So those are going to do the same thing. Yeah. But anyway, so now getting to operators. So we have all these different values. You can print them all or whatever. But what if we want to actually, compare these different values and, see how they interact with one another? Or like, for example, if you had two different numbers, like your age, I don't know, 30, you're 30 years old. Congratulations. You have, if you have multiple different numbers and you want to, do math with them, for example, right? You could do print my age plus your age, and it'll add those two numbers and then print them. Print the result as a string. Because it prints 50, right? And I could do parentheses, right? And blue is going to follow essentially the order of operations. So I could do parentheses and I could do divided by 10, right? So the slash is going to be divided by, the plus is going to be addition, right? And then this little star symbol, like if you hold shift and press 8, that's going to be multiplication. I do times 9, right? And I can do minus 10 to the power of, using this little caret stick. It's shift and then 6. So I do 10 to the power of 3, which is going to be 1,000. So now I have a negative number, right? So you could do lots of like math things. Those are the basic operators for math. Then there's also some operators for booleans. So you can do example boolean, and you could do equals equals other boolean. So there's a difference between this. There's equals here and this equals equals here. So the equals is setting a value, right? You're defining a variable, so you can define a variable just on its own, right? You can just do define local some variable and just leave it like that, right? It's a name of a variable that doesn't reference anything, right? It's just nil. You can also do you could also set it equal to nil, and then you can specifically define that, but it does the same thing either way, right? And typing nil that's just an empty value, right? But this equal with one equal sign is setting a value, so it's taking this and it's putting it inside this variable, right? This double equals right here is comparing two values. So we're saying, is this value the same thing as this value? And well, obviously they're not. There's one of them's true and one of them's false. So equals equals is going to be, so this whole thing is going to be false because these two values are not the same. You say prints false. But if I change one of these, I change this one to be false, then now prints true because false is equal to false, right? These are the same thing. Now another thing you can do is you don't necessarily have to do booleans for this. You can do my age, right, is equal to your age. Oops. So you can compare two different numbers. You can compare two different strings, right? You can compare basically anything, right? So we can see that my age is not equal to your age. But if I change my age, then now they're equal. They're both 30, both the same number, right? And the same thing for strings and whatnot. So that's equals equals. There's also greater than and less than. So you do like print my age less than your age, right? I can make my right now it's going to be false because it's equal to. It's not less than, right? But I can also do print my age less than or equal to your age. So you just do a less than sign and then equal to sign, and that's less than or equal to. My age is greater than your age. Print my age is greater than or equal to your age. And you can see all those print as would be appropriate, right? My age is the same as your age, and so only the ones that have the equal sign are going to be true, right? And there's some other operators that are used with booleans specifically, but I'll get into that in just a second. So we have all these variables. I want to keep all these variables up here, and now I'm going to go over a thing called if statements. And essentially, an if statement is a conditional statement. So you're saying, if A is true, then do B, right? But if it's not true, then don't do B, right? So if true, I can literally just type true, then print hello world. Well, true is always going to be true, right? So the thing you put here between the if and the then, all these words are just keywords in Lua. The thing you put between the if and the then is going to be a boolean. So you can literally just put a true, and this will always run, right? If true, then it'll always print hello world. Because true is always going to be true. If false, then, well, it's not going to run because it's false, right? It doesn't print it. But if I did if example boolean equals other boolean, it's going to print because these two are equal. So it's going to look at these. It's going to say, okay, are these two the same thing? It's going to be true, right? So this whole thing is going to be true. So it's going to essentially be the same thing as if true then, right? And so it's going to print. So this can be really useful for determining like actual game mechanics and other things like that. This is like essentially how you define conditional statements, right? So like, if my name equals John, my first name. If my first name equals John, then like, you know, maybe you do run some code to like give me money. I don't know. So you give the player money if their name is John. I don't know. Just a random example, right? Or you could do, another thing you could do is not equal to. So rather than doing two equal signs, you replace the first equal sign with this little squiggly character, which is shift, and then like the key right under escape. A lot of other languages have it as an exclamation mark. So make sure not to mix that up. So this means not equal to. And you can see, since my name is equal to John, then this is false, right? So one other quick thing we can do with if statements is, so we say, okay, so if my name is not equal to John, then we print give me money or whatever, right? We can also say else print don't give me money. And essentially what this is doing is it's saying, so if this one's true, it's going to run this, and it's not going to run this. If this one's false, then it's not going to run this, and it is going to run this. And so essentially, this is like the default in the case that this isn't true, right? We can also do else if my last name equals whack, then. And so what this is doing is saying, alright, so if my first name is not equal to John, then print, give me the money. Alright, so now if my first name is equal to John, and then thus this is false, right? So if this is false, then we go down here to this else if, okay, so is my last name equal to whack? Well, it is, and so then we run this instead. You can also add an else after that. You know, do something else here. And you can do strings using a single quotation, like or the little apostrophe instead of quotation marks. Those both work to create strings. So that's what that was there. Anyway, so this is sort of, so the else is like the default case if none of the ifs are true, right? But the ifs, you can have multiple ifs, and you can have as many else ifs as you want. So like, you know, like local some number, right, equals, I don't know, 30. You do if some number is greater than, I guess if some number is less than 5, then, you know, do something, you know, a small number, right? Do else if some number is less than 10, right? Medium number. You do else if some number is less than 15, then print large number, right? You do else super large number, sure. So like essentially you can string multiple if statements, and the key thing to remember here is that only one of these is going to run, and it's going to check the conditions from the top to the bottom, right? So if this condition is true, it doesn't matter if these conditions are true. This condition will take priority, right? And then this one, and then this one, and then the default one, right? But yeah, so this can be useful for lots of different things. Say, for example, you have like a system where you wanted to give a player a random, I don't know, a random pet, for example. If you have like a simulator game, right? You might have, you know, some number equal, or like you might have like roll, for like you're saying you're rolling your chances, right? Like you're rolling a dice, right? You map that random from, let's see, like 0 to 100, right? To say, okay, is roll less than 5? Is roll less than 10? Is roll less than 15? So maybe instead of these numbers, maybe do, okay, 5, then maybe do 50, then maybe do 100, or maybe do like 80, and then the roll less than or equal to 100. So what this would be doing is essentially like, maybe this is going to be legendary, right? This is going to be rare. This is going to be uncommon. And this one's going to be common. And this math out random, this is just generating a random number between 0 and 100, which is kind of a little utility function. And so essentially what it's going to do is it's going to generate a random number. And so we're going to look at that random number. Is it less than 5? If it is, then that's, you know, there's a 5 out of 100 chance to get that. That's a 5% chance. Yeah, that's legendary, right? Or if it's less than 10, but it's not less than 5, then that's another 5% chance because it's between 5 and 10. If it's less than 30, but it's not less than 10, then it's between 10 and 30, so that's a 20% chance. If it's less than 100, but not less than 30, or if it's less than or equal to 100 and not less than 30, then it's between 30 and 100, and so that's a 70% chance. And so you can use this to do a chance system where different things have different chances, right? So that could be useful, right? Another thing you can do is you can combine multiple statements, right? So I can do if first name is equal to John and my last name is equal to whack. And so there's this and statement, but there's also an or statement, right? So I can do or my last name is equal to whack. Maybe my last name is actually equal to walk, right? And so the difference between the and the or is essentially and requires both conditions to be true in order for the ultimate condition to be true. So like back here, right? When we have this is essentially one big boolean. And you could even define like false and false, right? And that's going to be true. Or maybe not. Maybe it doesn't like that. I don't know. But but this whole thing is one big Boolean. And the Boolean is true if both of these conditions are true. If either one of these conditions are false, or if both of these conditions are false, then the whole thing is false. But if I do or, and change my last name to walk, right? If either one of these conditions is true, so if this one's true, then the whole thing will be true. If this one's true, the whole thing will be true. If both of them are true, the whole thing will be true. So an or is sort of less restrictive than an and, right? You can see, even though walk is not equal to whack, right? Since this condition is true, then the whole thing is still true. But if I change this to an and, well, my first name is the same, but my last name isn't the same. So it's going to be false and it's not going to run. And you can kind of, string these 21. And it gets a little bit confusing when you're stringing both ands and ors. I'm pretty sure ands take priority. So I think this will, so even though my last name doesn't match, so my first name matches, my last name doesn't match, and my age is greater than 21. But, so this whole thing right here is going to be false, and then this one's going to be true because my age is greater than 21. So it should still run. Yeah. And so essentially, you can put parentheses around these. I usually just always put parentheses when I have like a bunch of them, just to make sure it's clear. The and here takes priority, right? Because there's a difference between that and like, doing this right here. Because in this case, it says, okay, I guess in this case, it's still just going to be true. But we're going to say, okay, so if my first name is John, okay, my first name is John, and we need this whole thing to be true. Well, let's look inside this, right? So my last name equals whack. Well, that's not true. Or my age is greater than 21. Well, so my age is greater than 21, so that's fine, right? So, but then maybe my age is 10, right? So then this isn't going to be true, and this isn't going to be true. And so this whole thing is going to be false, right? And so it's not going to run. But then if I move these parentheses, and I focus on the and first, then it's actually going to be true. Because, okay, actually, no, it's not. Never mind. Yeah, it's not going to be true. But there are cases where it does matter where you put the parentheses. But yeah, anyway, so those are if statements. They're pretty cool. And you can do if statements inside of if statements. If your age is less than 10, then, I don't know, print, yay, I don't know. So you can do if statements inside of if statements inside of if statements. And notice it like indents it each time you go another level. And that's where a thing called scope comes into play. So these variables are local variables defined at the very top of the script. And so they're accessible basically anywhere down here, anywhere in the script underneath. And they're also accessible in higher levels where you have these indents, right? And so I can go down here and I can do print your age, right? And that'll run just fine. Well, except the code doesn't run because the value isn't true. So I'm going to replace that with true, right? And we can see that it prints your age, right? But if I defined, so if I had another thing here, if true then, and I defined your age right here, even though this is being defined before this is running, and even though this is running every single time, right? This is always running because true is always true. It doesn't recognize what your age is because of a thing called scope, right? So it's going to print nil because it doesn't recognize that there's any value called your age. And that's because this is a local variable. And so scope is essentially where you can see a value from. So my age can be seen from anywhere in basically the rest of the script, right? So it can be seen from here on down, right? And it can also be seen in higher levels, right? Where you have the indents. And you can go as many indents as you want. I mean, technically the indents themselves don't actually matter, to be clear. You can just remove all the indents and it works the same. But the indents will automatically appear and kind of show you the different levels. Because there's different things that create these different levels, right? So if statements will create a new level, a new scope level, right? So this is a different scope than this whole thing, right? And this is a different scope than this. And your age is limited, because it's a local variable, it's limited to this scope. So I can do like print your age here and it'll recognize it, right? Because it's in the same scope. You see it prints 30, but then the other one prints nil because it doesn't recognize it because it's outside of the scope, right? But then if I change this from a local variable to a global variable by just removing the local keyword, then this becomes a global variable, which the scope is basically anything that comes after it, right? So anything after this line runs, then it'll recognize your age. But in general, you want to keep your variables local and then just put them up here, and that works the same as a global variable. And then if you want to limit where you can see a value, then you can, some other value, then you can specifically define it in some specific scope that you want it to be limited to, right? So this is only going to be visible throughout here. All right. And another thing to note just really quick, so we have your age, right? So we print your age or whatever. And if we do if true, then, just to create a different scope, right? Then I can do local your age equals 40, right? Then if I do print your age. So this is kind of an interesting thing here, right? So in theory, if you're looking at this and you define your age as 30, right? And you print your age, it's going to print 30, right? And then, if true, then, well, true is true. So you go over here and you say, okay, local your age equals 40. So is this going to print 30 or is this going to print 40? Well, actually, it's going to print 30 because this is a different variable than this, even though they have the same name, because this is in a different scope, right? So I run this, it prints 30, right? It doesn't change this your age value. But if I print it up here, it's going to print 40. So now it's going to do 30, 40, 30, right? This is the 30, this is the 40, this is the 30. And so these two variables are different variables. And so if you wanted to change this variable as you're going, you can remove the local keyword and sort of treat it like you're creating a global variable. You're not really, you're just editing a variable that already exists. And so you don't need the local keyword. The local keyword defines it as a new variable. But since the variable already exists, if we just do this, then it'll actually change this variable rather than defining a new one in a different scope, right? So now it changes the original variable, and so now this one prints 40, right? So that's another key thing to keep in mind. But yeah, I think that's going to be the end of this episode. In the next episode, we'll probably get into loops and while loops, and also probably functions, which I've talked a little bit about functions, just talking about like the print function, right? But I'll get more into what a function actually is and how you can define your own functions, which is super useful. But for now, I hope you enjoyed this video, and I will see you next time.